Welcome back, students. Here in this session I am going to discuss about how that particular string is going to be accepted by the finite automata. Here this is the finite automata. Here this how that particular string is going to be accepted by the finite automata. See here, this is state C, right? Here how we are going to check whether the given string is accepted by the finite automata. If the given string is going to be reached the final state, if the given string is going to be reached the final state, then that particular string is accepted by the finite automata. Then that particular string is going to be accepted by the finite automata. Right? See here, check the given string 11010 is accepted by the finite automata or not. Here, while we are going to processing the string on the given finite automata, we have to start from the initial state, right? Here, this is the string now. Now q equals to, what are the number of states? A comma B comma C, right? States are A comma B comma C. Now, what are the number of inputs? Sigma equals to 0 comma 1. Sigma equals to 0 comma 1. These are the number of inputs. Next, here what is the transition function here? Transition function, here already transition diagram is there. That's the reason we have to draw this transition table, right? Here 0 1 A B C, right? Which one is the initial state? A is the initial state. Which one is the final state? C is the final state, right? A on 0 is A. A on 1 is B. B on 0 C. B on 1 A. C on 0 B. C on 1 C. This is the transition table, right? Next, here which one is the initial state here? Which one is the initial state in this case? Here q naught. Here in DFA, what are the number of tuples? Q, sigma, delta, Q naught, F, right? We have to define these 5 states while we are going to perform the operations on the DFA. Here Q, what is Q? Q is A comma B comma C. What is sigma? 0 comma 1. What is delta? See here, this is the transition diagram is there. By seeing the transition diagram, I am drawing this transition table. Next, Q naught. Q naught is the initial state. In this given graph, which one is the initial state? A is the initial state. Why? Because A is indicated by this arrow mark. A is indicated by this arrow mark. That's the reason A is the initial state. Now, which one is the final state? Which one is the final state in this given example? F equals to C is the final state. C is the final state, right? Up to here clear? Here DFA is consisting of 5 tuples Q, sigma, delta, Q naught and F. Q is the number of states A comma B comma C. Sigma is the number of inputs 0 comma 1. Delta is the transition function. Here by seeing this transition diagram, we have to draw this transition table, right? Next one is a Q naught. By seeing this graph, here arrow mark is indicated. That's the reason we are saying that A is the initial state. Here F is there. F is the final state. F is the final state, right? F is the final state. We have to draw final state is indicated by the this double circle, that is C. C is the final state, right? Now, we are going to check whether the given string is accepted by the finite automata or not. How we are going to check the given string is accepted by the finite automata? If we are going to reach the final state, while we are going to process the string, see here, what is the string here? First example, in first example, string is 11010. 1110. By seeing this one, if we are going to reach the final state, so this string is going to be accepted by this finite automata. This string is going to be accepted by this finite automata. Now I am going to processing this string, right? Here delta, which one is the initial state? A is the initial state. What is string? 11010. This is my input string. So first we have to process this one. What is A on 1? A on 1 is B. So delta of, here while we are applying one input on A, we are getting which state? Here we are applying one input on A, we are getting B, right? So B, right? What are the remaining inputs? 1 0 1 0. So we have to write 1 0 1 0, right? Remaining input string is, already we processed this one. So that's the reason we have to leave this one. So whenever we are applying one input on A, we are getting B state. So we have to write here B. Then remaining string is 1 0 1 0. So we have to write 1 0 1 0, right? Now what is the next input symbol here? 1, right? B on 1, we are getting A. What is our symbol? Here what is the next state? Processing state is delta of A. B on 1 is A. Already this one is processed. What is the remaining strings? 0 1 0. So remaining string is 0 1 0. Remaining string is 0 1 0. Now what is our current input? Is 0. Current input is 0. A on 0. A on 0. A on 0 is A. A on 0 is A. Delta of A on 0 is A. Already this 0 is processed. What is the remaining string is 1 comma 0. That's the reason here we have to write 1 0. Right? Now my string is 1. Right? A on 1. A on 1. A on 1. What is A on 1? B. A on 1 is B. So A on 1 is B, B on 0, right? Already this one is processed, so we have to leave this one. Next processing symbol is 0, B on 0, B on 0, C. We are reaching this C. B on 0 is C. B on 0 is C. Here, in my example, in my DFA, which one is the final state? C is the final state. See here, C is the final state. We are reaching this C. We are reaching the C state. So, while we are going to process this string, on the given finite automata, we are reaching the final state. So, if we are reaching the finals, therefore, we are reaching the final state. So, string is accepted. String is accepted by finite automata. Right? If we are going to reach the final state, then the string is accepted. See here, if we are not going to reach the final state, then the string is not accepted. Check this second example. See here, string is, here I am going to write here. See here, our next string is 110101001. Same transition diagram. See here, What is my Q? My Q is A comma B comma C, right? What is my input symbol? Sigma is 0 comma 1. What is my initial state? Q naught. Q naught is A. What is my final state? F. My final state is C. Here I am writing this C here. Now, here I am not going to draw here transition table. Directly by seeing this transition diagram, we are going to solve the given problem. See here, delta, I am going to process this string. What is my initial string, initial state A? What is my string? 1 1 0 1 0 0 1, right? This one. A on 1, A on 1, B. A on 1 is B. Delta of B 1 0 1 0 0 1. B on 1, right? B on 1. B on 1 is A. B on 1 is A. B on 1 is delta. B on 1 is A 0 1 0 0 1. A on 0. A on 0. A on 0 is A only. A on 0 is A. Delta of A 1 0 0 1. 1 0 0 1. A on 1. A on 1 is B. A on 1 is B. So, A on 1, delta of A on 1 is B 0 0 1. B on 0. B on 0 is C. B on 0 is C. Delta of C is 0 1. Right? C on 0. C on 0. C on 0 is B. Here I am going to write here. C on 0 is B. B on 1. B on 1. B on 1 is C. B on 1 is A. B on 1 is A. We process the complete string 1 1 0 1 0 0 1 on the given finite automata. We process the complete string now. Now here, after processing the complete string, what we are getting here? Which state we are getting here? A. Here we are getting the A state, right? We are getting the A state. It means that A is not the final state. A is not the final state. That's the reason here this string is not accepted. String is not accepted by the finite automata. String is not accepted by the finite automata. Up to here clear? Here, if we are going to reach the final state, then the string is accepted. If we are not going to reach the final state, then the particular string is not accepted by the finite automata. Now, here, this is the example problem. Homework problem, you have to perform this one. Here in this case, take the two strings. Here one is A, B, B, A. Here, check whether the given string is accepted by this finite automata or not. In this case, Q0 is the initial state, Q3 is the final state, A comma B are the input symbols. Now you have to check this one, A, B, B, A. Next is second example is AB, 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 AB. Here, these two strings, you have to write these, you have to solve these two given problems and check whether the given string is accepted or not by using this finite automata. By using this finite automata, these two strings are accepted or not. If you are going to reach the final state Q3, then the string is accepted. If you are not going to reach the final state Q3, then the strings are not accepted. I will write one Google form. Then you have to solve this given problem and you have to upload this thing on your Google form. Right? Thank you.